Hello. We are going to start with the mean and variance of a discrete random variable. Mean also called as mathematical expectation. It called as mathematical expectation. It is also called as the expected value. Is the expected value denoted by mu. This is called as mu. Okay. Variance of x. Yes, we'll have to learn the formula directly. Now, both the formulae I will give you. Now, first of all, expected value, that is the mean, is nothing but summation of x into p of x into p of x. And variance of x will be summation of x square into p of x minus expected value, that is that is to make sure that okay. So we'll start we'll take some problems from the government textbook, right? So go to government number 141 of your mathematics distributions, right? 10 from says 8.1. 8.1, we'll go to question number 10, right? Okay. So they are asking expected value and variance of x, where x is the uppermost face of a fair die. X is the uppermost face of a fair die. Okay. So x can take up certain values of a fair die. That means we are supposed to consider only one dice. So x can take up 1, 2, 3, 4, 5, 6, all these values. Then let us write down p of x. P of x is the probability of that particular event, which is x. Now on a die, if the uppermost face is 1, if the uppermost face is 1, so this is one event out of total 6 faces of a die, right? So the probability of this is 1 upon 6. Okay. Likewise for see, try and understand, n of s is equal to 6. There are 6 cases. Only one event. There is only one event in which you can see 1 on the top. If you look at the top, okay, so it is 1 upon 6. Or 1 upon value e of is equal to sum. Okay, guys. So I think there was some technical issue due to which I will have to restart this. So we were at this point. We got x as 1, 2, 3, 4, 5, 6. P of x is equal to 1 upon 6, 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 and 1 upon 6. This I had explained already to you. Then x into p of x. See, because expected value, that is the mean, the formula is summation x into p of x. So x into p of x, this column should be clear, and we have to make it. So multiply 1 into 1 by 6, that is 1 by 6, 2 into 1 by 6, that is 2 by 6, 3 into 1 by 6, 3 by 6, 4 into 1 by 6, 4 by 6, 5 into 1 by 6, 5 by 6, 6 into 1 by 6, 6 by 6. Now don't reduce anything, don't write this as 1 upon 3, because see, mathematically it is right, but then we'll get a common denominator if we don't cancel. right? So this is upon 6, but then we'll add all the numerators. 1 plus 2 plus 3 plus 4 plus 5 plus 6. That is equal to 21 upon 6, right? Which is 7 upon 2, 3.5, right? Then variance of x, summation x square into p of x minus expected value square. Now expected value, we have already got the value of the expected value is 3.5, but then I'll take 7 upon 2 for calculation purpose, minus 7 upon 2 the whole square. Okay, just a second. Or rather, we can also take 21 upon 6 for, to make the calculation much more simple for LCM and all. So we'll take 21 upon 6. I'll tell you why later on. Okay, now x square p of x. X square p of x, this column will have to prepare. So prepare x square into p of x. X square into p of x, how to calculate x square into p of x? Just multiply x with x p of x. Okay, so 1 into 1 by 6, that is 1 by 6. 2 into 2 by 6, 4 by 6. 9 by 6, 16 by 6. 5 into 5 by 6, 25 by 6. 36 by 6, and calculate the total over here. Okay, just calculate the total, right? The total is 91 by 6. Okay, so put that value over here, 91 by 6. So 91 by 6 minus 21 into 21, 6 into 6. Take the LCM, multiply and divide by 6 to make the common denominator, right? Hence I had taken 21 by 6. Okay, you can also take 3.5, you can also take 7 by 2, that is your choice, basically. Okay, so this is 6 by 6, 91 into 6, 546 minus 441 upon 36. So that is 5 and 0 and 1, 105 upon 36. If you reduce this by 3, the answer will be 35 by 12. If it is easy for you to get it into decimal, then please do it. Otherwise, if it's very difficult for you to divide it, leave it in a reduced fraction. Don't keep it as 105 by 36. At least put it in reduced fraction. Okay. So this was the first problem of your mean and variance part. The calculations are pretty easy, provided you don't make any silly mistakes, right? So page number 141, we'll go to the second question. Okay, question number 12, sorry. From page number 141, exercise 8.1, two dice are thrown simultaneously. So first of all, I'll just prepare the sample space 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So this is the sample space. Okay. And what is x over here? What is the random variable x? X is nothing but number of sixes in two throws. So if we are throwing the dice two times, there can be zero number of six. Okay, first die, second die, both will not give a six. There will be one six. So it can be six or non-six or non-six and six, right? Any one of the die will show six. And the third case is all the all the two dice will throw, it will show you a six. Okay, so P of X. Now every event is out of 36 total events. So 36 is the sample space. There are total 36 events, right? So probability of getting two sixes is only one event. See, one out of this entire lot of 36. Okay, so answer is 1 by 36. Okay, for two sixes. For one six, let's go back to the sample space. See this, whatever I'm highlighting in red. Okay, these are the cases in which there is only a single six, right? So these are 10 cases out of 36 events. Okay, and zero sixes. Okay, look at this, whatever I'm doing, this all blue colored events. Okay, all these blue colored events. Okay, this does not have six in it, right? So these are total 25 events. So 25 by 36. Now first of all, what they are asking in this problem, the probability distribution we have just made. Okay, now first of all, what they are asking is they are just asking expected value. Okay, expected value. They're not asking the variance, because in question number 12 they have said find the expectation of x. So they're just asking e of x. So this problem is so simple. X into p of x. So multiply x into p of x. So this is 0, 10 by 36, 6 by 36. So the total of this is 16 by 36. So 16 by 36, that is equal to 8 by 4, 4 is 4, 9 is 4 by 9. You want to divide, you can divide, otherwise keep it in reduced fraction. Okay. Let us go to question number 11 of your government textbook. They're asking mean, that is the expected value of three tosses of a fair coin. So we'll just prepare a sample space. TT, TT, HH, HH, TT, HH, TT, HH, TH, 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 TH. So these are three tosses of a fair coin, right? Okay. So X is what? X is the number of heads, right? So how many heads are there? Okay, in three tosses. So there can be zero heads, there can be one head, there can be two heads, or there can be all three heads for three tosses, right? So that's our probability distribution. So first we'll have to prepare a probability distribution, right? So let's prepare a probability distribution. Zero heads out of three tosses, one head out of three tosses, two heads and three heads. So P of X, zero heads. That means not even a single case will have head. Okay, so that will be this one, right? Zero heads. So that is one event out of eight events. Okay, one head is nothing but this case and this case, the blue colored case, that is showing only one head. See, there is only one head over here. So these are three events out of eight. So these are three events out of eight. So you can write 3 by 8. Then uh, two heads, the yellow colored events. Okay, the yellow colored events. So these are having two heads. So three events out of a total of eight events. And the last one is all three are heads. So that is only one event out of eight events. I'll show you which one. It's this one. One out of total eight events. Okay, so we have got the probability distribution. Now we'll calculate the expected value, which is the mean summation of x into p of x. So x into p of x, 0, 3 by 8, 6 by 8, okay, and 3 by 8. I'm just multiplying this two. So the total of this, okay, so that will be 6 plus 6, 12 by 8. That is the total. 12 upon 8, 3 by 2, which is 1.5, right? Okay. So that was question number 12. Then let us go to question number 16. Okay. See, question number 13, 14, 15, you can refer through some reference books. Okay. So question number 16, I'm solving. 70% of the members favor, they are in favor, okay, and 30% oppose the proposal in a meeting. So probability of favor, they are favoring a particular decision, is 70%, which is 0.7, and probability of opposition is 30%, which is 30 upon 100, which is 0.3. X takes up a random value 0, so X will take up 0. When does it take 0? If a member opposes, so 0 will take if it is opposed. Okay, if it is opposed, right? And it takes up value 1. X takes up value 1 if it is in favor. If a member opposes, if a member is in favor, then X will take up the value 1. Okay, so we'll write down the respective probabilities 0.3 and 0.7. They are asking expected value. Expected value is summation X into P of X. So X into P of X, we are just calculating 0 into 0.3, that is 0.3. 1 into 0.7, 0 into 0.3, that is 0, sorry. 0 into 1 into 0.7, that is 0.7. So the total is 0.7. That is the expected value. Okay. Now they are also asking the variance. Variance of X is equal to summation X square P of X minus E of X the whole square. Minus E of X the whole square, right? E of X, we got it as 0.7 the whole square. I'll just write it out as 7 upon 10 the whole square. Okay, now X square P of X, we have to prepare this column X square P of X, right? So X square P of X, just multiply X with X P of X, you'll get X square P of X. 0 into 0 will give you 0, 1 into 0.7 will give you 0.7, and this is 0.7, right? So let's go back to the calculation. 0.7 minus 0.7 the whole square. So this is 7 upon 10. 7 upon 10 minus 49 upon 100. Multiply and divide with 10. LCM I am taking. So 70 minus 49 upon 100. 70 minus 49 is 21 upon 100. So answer is 0.21. Right? Yeah. So next one. Let's take one problem from the miscellaneous exercise. Right? Okay. So go to part 1 of your miscellaneous exercise, which is on page number 155. There are many problems with regards to mean and variance. You can just go through it and solve. But then one problem I'm going to solve specifically. Okay. It's on page number 156. Please do this problem for the boards. Right. So see what they have given. Page number 156, question number 11. Question number 11. A player tosses 2 coins. So let's make a sample space. TTHH, TH, TH. 4 events in all. This is the sample space. Okay, he wins rupees 10 if two heads appear. Okay, so now this time x is equal to 0, 1 and 2. Why we are taking x as 0, 1 and 2? Because when two tosses are done, the number of heads can be 0 out of the two tosses, or it can be 1 out of the two tosses, or it can be both heads into tosses. P of x, P of x. So it's 0 heads. So when it is 0 heads, it will be only one event out of 4. One head, it will be two events out of 4. And both the heads, it is again one event out of 4. Right? So a monetary value is assigned. If you read the problem clearly, M is the monetary value. So he wins rupees 10 if two heads appear. So this is in rupees. Okay. He wins rupees 2 if no heads appear, and he wins rupees 5 if one head appears. So this is the data which is given to us. Now they are asking expected value and the variance of the winning amount this time. They are asking expected value and the variance of the winning amount. So slightly different this problem is. So expected value of winning amount is equal to summation mpx this time. It cannot be xpx because a monetary value is attached to it. So it is summation of mpx. So we will prepare a column that is mpx in our table, right? M into px. So 2 into 1 by 4, which is 2 by 4. 2 into 5 by 5 into 2 by 4, that is 10 by 4. And 10 into 1 by 4, which is again 10 by 4. So the total is 22 by 4. You take a look at the calculations. The total is 22 by 4. So expected winning amount is 22 by 4, which is rupees 5.5. Now variance of the winning amount. Variance of the winning amount is equal to summation m square p of x minus expected value square minus expected value square. So we'll prepare a new column that is m square p of x. Okay. M into mp of x is m square p of x. So 2 to the 4 by 4, 50 by 4, and 100 by 4. We are multiplying these two columns, the entries in these two columns with each other. Okay, so the total over here is 54 and 100, that is 154 by 4. Okay, 154 by 4, right? Correct. So we'll put this value in the calculation. 150 by 4 minus expected value, that is 5.5 the whole square. Now it is better for us to keep it in decimal only in this problem. Okay, so 5.5 the whole square is 30.25 if you just calculate, and 154 by 4, this you can just divide. Let me also divide 154 divided by 4. Okay, I'm doing a manual division over here. The answer is 38.5. So this is rupees 8.25. So this is the variance of the winning amount. Okay, now let us understand one more problem. That is the last problem in this mean and variance part. It's quite easy basically. Okay, so go to page number 156. Okay, page 156. See, x is given as -1, 0, 1, and 2. And p of x, this time they have given us a formula, 3 minus x upon 10. So when x is -1, so the first calculation will be 3 minus -1 upon 10. I'm putting -1 over here. So this is 4 upon 10. The first answer will be 4 upon 10. When x is 0, so put x as 0. 3 minus 0 upon 10, that is 3 upon 10. When x is 1, so this will be 2 upon 10. And when x is 2, it will be 1 upon 10. So we got a table over here. Okay, from the formula we got the table. Now calculation of mean and variance is very easy. You can just go ahead and do it for self-study. Okay, so that is all about mean and variance of a discrete random variable. Okay guys, thank you.